Welcome to today's webinar. My name is Almi Bradfield van Wyk, and I will be presenting exposure monitoring in the construction industry. If you are watching our webinar live, there is a Q&A tab at the bottom of the screen where you can post any questions which will be answered at the end. Our details will also be on a follow-up email, which will include the link to the recording of today's session and some online resources. So let's start with occupational hygiene, what it is. Chemicals often used in the construction industry, their health effects. What is going to happen there? Is it just someone coming in, reading some measurements from a screen? Someone walking around with instruments? When we look at exposure, how do we know when we need to reach out to an occupational hygienist? And when it comes to fitting respiratory equipment, how do we identify leaks and how do we know what's appropriate? So in short, the purpose of occupational hygiene is to look at all of these various factors, assess all of the risks involved, and determine what is necessary to achieve control in order to control the risks. To the unfamiliar, occupational hygiene is a job that is very mysterious. What is it? What does occupational hygienists do? Many people guess that it's dental assistants or someone who works in cleaning bathrooms and toilet facilities, or even people in the food industry. Although occupational hygienists may assist with all of these type of workplaces, there is much more to occupational hygiene that meets the eye. Occupational hygiene is preventative health for the workplace. It is critical in any kind of workplace for the health and safety programs because it's all about prevention and stopping people from becoming unhealthy and unwell from the work that they do. Occupational hygienists play a vital role in raising awareness of hazards in order to recognize hazards, evaluating the hazards and the extent of them, and controlling them in the workplace. This involves anticipating practices and chemicals, looking for hazards in the workplace and anything that can cause disease, and control the hazard so that the disease does not develop. The focus is on prevention of illness and of disease, and not just treating injury. Occupational hygiene is about ensuring that whatever workers may be exposed to today doesn't affect them in the future, doesn't affect them when they change jobs, also doesn't affect them when they change careers, or when they go on to retirement. Occupational hygienists consider the potential impact on the surrounding communities as well as the environment, not just the workplace and the workers themselves, which is of particular concern because when in construction, all of the projects are finished and the project moves on, whatever happened within that environment still persists or was controlled and is no longer there. So let's have a look at how do we go about this preventative actions. How do we ensure workers go home as healthy as when they started? How do we improve worker health and increase life expectancy? Reduce the number of people who leave employment early through injury or illness? Lower social and healthcare costs? Maximize worker potential? Or just making a workplace more efficient through processes with technological improvements and increased productivity? So in the broader scheme of things, if we delve in a bit further, occupational hygiene is the science and art devoted to the anticipation, recognition, evaluation, control, and review of hazards to ensure that the continued protection of the workplace from hazards that may result in injury, illness, or affect the well-being of workers. So if we look at anticipation, it involves identification of potential hazards in the workplace before they are even introduced. In construction, this involves the planning phase, when you plan what processes are all going to be involved within your process, within the larger scope of the project, and what hazards will be mitigated by which of your various subcontractors. Recognition means the identification of potential hazards of a chemical, a physical agent, a biological agent, or adverse economic situations that could pose risks to health. Evaluation is the evaluation of the extent of exposure to the chemicals, physical, biological, or even ergonomic risks. This involves the measurement of personal exposure of a worker to the agent or the hazard in the workplace, particularly at the relevant interface between the environment and the body. So this is where your routes of exposure comes into play with your evaluation. This is also where exposure monitoring comes into play, where we establish what the extent of the exposure is to employees. And all of these factors also take into account the breathing zone, the hearing zone, the assessment of data in terms of recommended occupational exposure limits or the WES, and what criteria exist moving into the control. Controls include the chemical, physical, or biological or ergonomic agents. These are either through engineering controls or other means where the evaluation indicated that control is necessary in order to reduce exposure. Occupational hygiene focuses on a preventative approach through the minimization of exposure to chemicals, physicals, or biological or ergonomic stresses within the work environment and the adoption of good ergonomic practices. Once controls have been implemented, it is important also to review, make sure that the controls are working, make sure that the measurements taken and the controls implemented have reduced or minimized employee exposure, and the process start all over again. We review, we anticipate, has anything changed, and we run through the whole process again to make sure that the process within the work environment remains controlled and we keep mitigating the risks. So before we continue, it's also important to know what the difference is between a hazard and a risk. The reason why this is important is because you can control everything, but it might be quite expensive if you do so. So if we look at the picture, we'll see there's an active volcano very closely situated to a town, and the hazard would be the volcano. The volcano has the ability to cause harm to the population within the city. The risk would be, what is the likelihood of this volcano erupting and causing harm to the city? So the difference here is the hazard being the thing that can cause harm, and the risk being the probability or the likelihood of that harm actually coming into play. In construction, it's very important to understand that it's an ever-changing environment, and assessing this risk of the hazards actually affecting harm is very important every time the change happens within the work environment. If we look at the exposure assessments, they are more than just chemical exposures, they are more than just airborne contaminants. They are stresses which have detrimental effects on employee health and well-being. And they include physical agents, chemical agents, ergonomic agents, psychological aspects, as well as biological agents. Physical agents would be examples such as lighting, noise, ventilation, thermal environment, is it cold or is it too hot, radiation, and vibration. Chemical agents comes in various forms. They could be gases, vapors, solids, fibers, liquids, dusts, mists, and fumes, and the list of chemicals are also quite long, and they also interact upon each other as well as interact with physical agents, which could have synergistic effects on the human body. Ergonomic agents include lifting, stretching, repetitive motions, overexertion, just to name a few. Psychological or psychosocial agents could include workload, stress from driving long distances, stress from having shift work or irregular shifts, work organization, working with valuable cargo, or even intimidation. Biological agents could include fungi, bacteria, mold, and even viruses within the workplace as well as among the workforce. Exposure assessments helps us to establish what is the risk that all of these hazards of these agents have on the workforce, and how do we help to control the health effects that is associated with them. In order to understand that, we need to know where is the most critical aspects that we need to focus on so that we can put the money and all of the effort into a place where it will actually bring a benefit and assist in control. Because if you look at all of the various aspects and all of the various stresses within a workplace, especially an ever-changing one such as construction, it is quite important to be able to pinpoint where is the most critical controls needed. And in order to do that, qualitative assessments or health risk assessments helps us to establish which of these are the highest risk and which of these requires the most imminent priority. Physical measurements of exposures, they will come in later after a qualitative assessment has helped to establish which of the stresses actually requires attention. When it comes to health risk assessment, they are the first step in the anticipation, recognition, and evaluation. Here, similar exposure groups are identified, which means groups of employees are grouped together where they conduct similar activities for similar duration using similar tools, similar materials, or even similar chemicals. And their exposures to stresses are categorized from low to high during an assessment in order to identify these critical areas which may impact on the health of the employees. From a health risk assessment, a monitoring plan can be established where employee exposures are physically measured for stresses to which they are exposed at a category of a moderate to high, which then saves cost in the long run, as low category stresses are viewed as being currently under control and requires review, not assessment, so that they remain under control. Health risk assessments should be reviewed and another assessment completed if there is any change in the work practices. As we know, in the construction industry with various phases, there is continuous change. But through a health risk assessment, we are able to better understand all of the phases and the various risks associated with them. And in such, we are able to better control each phase with the high risks associated with them. If we look at the quantitative assessment or the physical measurement of the stresses or the hazards, it is advantageous in order to gauge the extent of employee exposure to moderate or high risks as we identified during our health risk assessments. Routine measurements of hazards allow employers to monitor where employees are still being exposed to hazards, which may result in occupational disease. So physical measures are measures that we take for the high and moderate risks in order to determine the extent of the exposure of the employees. And this also enables us to better understand how the controls are needed, where the controls are needed, and how the agents within that workplace environment affects the employees. Where is the exposure coming from? How much exposure is happening? What are we doing to control this? And the next steps then follows after we know what the measurements tell us. An occupational hygienist conducts these measurements and they recommend controls based on the hierarchy of control to provide information for employers in order to protect their employees. This also assists in order to limit bias. This assists in order to indicate and actually show the physical environment within which the employees find themselves. And it also helps to understand if there has been controls that has been implemented, are they working or are they failing? Exposure assessments are not only an occupational hygienist coming into the workplace environment with all of the various tools and equipment and taking measurements. They also include medical tests, including blood tests or urine tests or lung function tests, depending on the gases that the employees have been exposed to in that example. And they give the metabolites that the employees' bodies have actually worked through during the exposure of certain chemicals or certain stresses, and also provide a measurement of the extent of that stressor within the employee's body. And they are also used as part of your qualitative assessments. Workplace exposure standards are there in order to assist with these measurements so that there is a level in order to gauge what is aimed at in order to provide a safe working facility. They are set at levels for which healthy adult workers can be exposed of during the course of their employment without adverse health effects. Workplace exposure standards are reduced or revised when new knowledge becomes available of adverse health effects for a specific hazard. And PCBU should also be aware that they should strive to reduce worker exposure to hazards to as far as below the WES as reasonably practicable. The primary reason for conducting a workplace assessment is to assess the risk to the health of employees. Where a less than satisfactory situation is indicated, so in other terms, where your exposures are above the WES or your statistical analysis indicate that there is an upper confidence level that is above the WES, that means that you are in an unsatisfactory situation and your employees are being overexposed. And this would require additional steps. These would be controlling your workplace environment, controlling the hazards, lowering the risk. So if we look at the WES, what is it? And how do they determine the WES? In terms of the WES, it is based on what the physical aspects is that happens within the body. What is the detrimental effects caused by a stressor? In terms of chemical workplace exposure standards, there are various different things that people look at in order to determine a WES, but the most important ones for very low WES, workplace exposure standards would be if it's irritants, simple asphyxiants, chemical asphyxiants, anesthetics, or carcinogens, which is the toxic effects that these chemicals would have on the body. And that is one of the reasons why the workplace exposure standard for these type of chemicals would be lower, because they have much more severe health effects on employees or more acute health effects on employees or really bad chronic effects. If we look at irritants, irritants cause inflammation to the mucous membranes, as an example. They can include hydrochloric acid, ammonia, ozone. We look at asphyxiants. Two is a simple asphyxiant or a chemical asphyxiant. Simple asphyxiants can be nitrogen, carbon dioxide, or even helium. What this means is that they displace the oxygen and deprive tissue from oxygen, which means that the person starts to suffocate. Chemical asphyxiants, examples include cyanide or carbon monoxide, and they are chemical asphyxiants because they compete within the body for the oxygen reserves of that person, which then causes the chemical asphyxiation. Anesthetics is the present of the action of the nervous system, such as, for example, chloroform. And carcinogens causing cancer could include asbestos or vinyl chloride. There are also other factors, such as unbearable odors, such as mercaptan, or as we know, hydrogen sulfide, the rotten egg smell, or toxic effects like the dusts of crystalline silica and lead. We look at the routes of entry. It is quite important so that we understand how to control risks to stresses. So if we are focusing today only on the chemical routes of entry, as we don't have sufficient time to focus on all of the routes of entry for all of the various factors. And in construction, it is also important to focus on these routes of entry, as with an ever-changing environment, there isn't a set place for employees to put on their PPE always and put down their PPE. So it is quite important for them also to understand how this interaction happens with the PPE that they have been given. And as with the ever-changing working environment, there is also not always set engineering controls that has been placed because they are always moving. So it would most probably be portable engineering controls that has been placed, or engineering controls on the equipment. And the last line of defense would then be the PPE as well. So when we look at the routes of entry, we'll start with the absorption of the skin. So chemicals that get into contact with the skin or the eyes can cause damage to the skin and the eyes. And if the skin is damaged, other chemicals can also be absorbed into the body. The skin has a natural layer in order to make it impermeable, but some chemicals have the ability in order to function with the molecules of the skin, such as lipids, that break this barrier and moves through the skin into the body. And as explained before, if there is a cut, for example, or a piece of skin that is damaged, some of the other chemicals that would normally not have been able to penetrate would penetrate the skin. So if we think about exposure, primary exposure here would be that there is no gloves or there is no apron, there is no additional barrier protecting the skin from contact with chemicals, or there is no spectacles worn when interacting with chemicals and the splash occurs into the eye. Or it could be that there was a pigskin glove being worn while working with solvents, and pigskin gloves being made of leather would absorb the solvent. Being in contact with the skin, it would provide no barrier before that contact happens. Secondary exposure would be when the gloves are worn. Exposure still occurs when the gloves are being removed. As the gloves are being taken off, care is not taken once the one hand is free of a glove, touching the second glove with the exposed skin and not realizing that there is chemical contaminant on that glove would be a secondary route of exposure. As well as when gloves are worn when working with a chemical or tools, and those gloves are removed, tools are picked up and moved around before they get cleaned or before they get packed away and not cleaned. That would also be an example of secondary exposure to the skin. If we look at inhalation, it's important also to understand that common irritants include detergents, soaps, organic solvents, acids, and alkalis. Common sensitizers are like plants during gardening, antibiotics, dyes, paint in the cosmetic industries. All of these various items. So if there is construction within refurbishing of buildings, it is also important to know and to remember what happens within this building. Is there any potential of something having been left within this building that you are entering when doing your work? The route of entry during inhalation includes the respiratory tract, which is the nose, the throat, the bronchi, and the alveoli. The target organs is the central nervous system, the liver, the heart, and most of the organs within the body, depending on the chemical having been inhaled. Exposure here could be primary or secondary. Primary would be that there was no masks worn, or that the mask worn was not the correct type, or that there was leakage, which would mean, for example, a half-face mask was worn, but the person did not shave, and leaks occurred due to this. Secondary exposure for inhalation include RPE not being fit tested, which also would lead to a seal if that mask does not fit properly. Storage of masks or respiratory protection could also result in the filter having absorbed all of this chemical within the workplace throughout the time that it has been stored. The person comes back from their off time and shift starts, they put on the mask, they think they are safe, but the filter has been absorbing all of this chemical while it was in storage, and now the employee is being exposed because the filter is full. Could also result during filter changes while there is contamination. So if your masks are being stored, even if they are being stored properly, if the checks are not being done on the respiratory protection, mold can grow. There could be dust inside of the respiratory protection as well. So it's quite important to look after your respiratory protection if wearing a mask that is not disposable, if wearing a hood, and if using any respiratory protection equipment. It is important to do the checks to make sure that when you put this on your face, there isn't any secondary exposure happening because you haven't cleaned it properly or because it hasn't been stored properly. When we look at ingestion, it is not often that we think about chemical exposure within the workplace as ingestion, but it is quite important if we consider that if there is, for example, a lot of dust being inhaled, that dust goes and gets stuck in the nose, for example, and the mucus, the system within our bodies, in order to clear the respiratory tract, in order to clear the nose, would then express mucus in order to get that dust to move either out of the nose or into a different area where it's not causing obstruction. And sometimes this can happen with all of that dust, for example, being swallowed, which would then lead into ingestion. So when we look at the nose, the throat, and the stomach, again, the target organs could be your central nervous system, the liver, and the heart, but it could also be others depending on the type of chemicals or dust that is being swallowed. And the primary route of exposure here, especially in the construction industry, would be that there isn't any dedicated places for employees to take smoker, or places where smoker is being dedicated is actually adjacent to the workplace and not sealed off, which would mean that there is contamination of the surfaces. There might even be contamination of the food that the employees have stored within their lockers or within bags even. And then they ingest this contamination with the food that they eat, thinking that it is safe. Secondary exposure would be having a snack or lunch without taking gloves off, and the gloves might be contaminated. Having a smoke after your shift, during a smoker break or after work, and not having washed your hands properly. Having taken gloves off and recontaminated hands. These are all examples of a secondary exposure route. When we look at the time-weighted average, this plays a part also with your exposure monitoring, and it is important to understand what is a time-weighted average and what does it mean for your occupational exposure monitoring. The time-weighted average is what is determined for the WES. So your workplace exposure is the limit to where your workplace exposure gets evaluated at, is your aim at what you need to be lower than. So if we look at the time-weighted average, it is an 8-hour averaging period. The WES is determined on this 8 hours, and it gets evaluated against the 8 hours as well. Oftentimes in construction, employees do not just work 8 hours. They might go a bit of overtime. There might be 10-hour shifts, or it's a critical project, it's time limited, and they even put in 12-hour shifts. So what does this mean? Simple. It just means that that 12-hour shift needs to be taken back and converted into an 8-hour shift in terms of the data, so that we can then determine the extent of the exposure for an employee working a 12-hour shift, but be able to compare it to an 8-hour workplace exposure standard. It's also important to understand that some substances have more acute health effects, even after brief exposures to high concentrations. And it's important that exposures above the time-weighted average concentration be restricted. The level of exposure, the exceedance of that is an indication of whether or not the controls are effective, or if there's still contaminants being released from a process. So in order to be able to see if the controls are effective, or if employees are being exposed to something more than what is safe, it is important to be able to compare any workplace exposure standard to the work that is being done for the time that employees are being exposed to it. And that is why it's important to understand the time-weighted average. If we look at the short-term exposure limit, it is a 15-minute limit. It is a 15-minute time-weighted average, which means that in a 15-minute period, the exposure is determined for the entire shift. And within that shift, the limit of this 15 minutes should not be exceeded. It is a concentration which is believed that workers can be exposed at continuously for a short period without suffering any consequences, such as irritation, chronic or irreversible tissue damage. The dose rate is dependent on the toxic effects. Narcosis is sufficient to a degree that the likelihood of accidental injury or impaired self-rescue or maternal reduced work efficiency. So the style is there for toxins and chemicals that have a much more acute or severe effect than chemicals that has a time-weighted average of 8 hours. The short-term exposure limit is also not separate or independent exposure guideline, and it should be used together with the time-weighted average for hygiene standards of 8 hours in order to protect employees from both acute and chronic effects. So what this means is that it should be taken into account whether a substance has a style and a time-weighted average for 8 hours, or if there is a ceiling limit that also needs to be considered, where that concentration must never be exceeded during any part of the workday. So if a chemical within a workplace has a ceiling limit, it means that that limit is the limit for the whole of the shift and must never ever be exceeded. Whereas a style is a 15-minute time-weighted average and an 8-hour time-weighted average for your workplace exposure standard. In conclusion, the occupational health field has a number of different specialists that work in protecting workers' health, and they work together. Occupational hygiene and occupational medicine both work in order to prevent diseases within the workplace. As seen before, work exposure monitoring isn't only done by an occupational hygienist, and some of the exposure monitoring can also be done by medical staff, such as the urine tests and the blood tests, in order to determine metabolites for employees having been exposed to certain chemicals and certain stresses.